After having escaped a number of traps in the floodplains, the deltas and the estuaries, and the coastal domains, the sediments, very much change their properties, enter the continental shelf. They enter a very different domain, a large area with little morphological changes, a little lateral confinement. In this clip, we will see how these sediments are modified, distributed, and deposited marine currents on the continental shelf. The very apparent flat morphology of continental shelves and the associated sedimentary processes can only be understood considering the effects of recent glaciation and associated sea level changes. This is what Europe looked like something like 15,000 years ago. Large glaciers and, as a consequence of the low sea level, large domains which are presently underwater were emerged. These are the future continental shelves. At high latitudes, glaciers were present, eroding and transporting towards the plains all sorts of sediments, typically poorly sorted and immature. Particularly when glaciers began their retreat, large amounts of sediments were deposited, ready to be transported away by rivers. Little vegetation was present, mechanic erosion was dominant. Rivers formed wide valleys, transporting the poorly sorted sediment to the coastal domains and further towards the sea. And there deposited sediments in prograde delta systems close to the shelf edge. Clearly, the area of the future continental shelf was characterized by a remarkable variety of sediments in terms of amount, type, composition, and distribution. This has a major impact on the kind of sediments dispersed in the continental shelf. With the improvement of climate conditions, sea level began to rise. In most places, sediments input from the rivers was insufficient and water depths of several tens of meters deposited. Marine currents, tides, and waves started moving around, distributing sediments, the coarse and fine-grained sediments which were deposited during the lowest end phase. In the slide, you see a map view of the North Sea and surrounding regions. The light blue colors are indicative of the shallow depths of the continental shelves. Current, whatever their origin is, are generally able to circulate freely. On the other side, however, in regions where, as the one between the United Kingdom and France, where the continental masses allow only a narrow passage, currents can be deviated and water velocities will increase, removing fine-grained sediments and leaving the coarse-grained deposits behind. On the map to the left, you can see the currents in the North Sea region, strong currents in these narrow zones. The map on the right shows the percentage of coarse-grained sediments, gravels in this case, found on the seafloor. There are a few important observations which you can gather from the map. First, there is quite some gravels on the seafloor. As we have seen, they were deposited during glacial times. Secondly, these bodies of coarse-grained sediments are not directly related to the position of present-day rivers and are rather controlled by the speed of the currents moving on the shelf. Speed of the water current exerts also a strong control on the architecture and spatial organization of these sediment bodies. Continental shelf deposits, such as the ones we have been discussing until now, are of the greatest importance in hydrocarbon geology. As you can imagine, you need to have a very good knowledge of these processes if you want to make meaningful predictions of the properties of your petroleum system. If substance is strong, then very large thickness of sediments can be stored in the continental shelves, up to several kilometers. Some of the sediments parked on the continental shelf, however, will not remain there forever and will be transported to the deep sea. We will see this in the next clip.